We're going to skip the first section. We're going to go right into the graphing section. So we're talking about functions today. Functions and relations. Functions and relations. So, first let's define what a relation is. It's basically an association of one set of numbers or things, in our case numbers, with another set. Basically, it's a relationship with an x and y. And in our case, we're going to give all the x's a specific name. We're going to call them the domain. And all the y's, we're going to call them the range. So let's define that domain. All possible x values. And the range is all the possible y values. Now, so far I've just given you definitions, but we don't actually really see what a relation is, or what a domain is, or what a range is. So that's what we're going to seek to do in the next few slides here. So, one more definition before we get going. What is a function then? Well, a function is, first of all, and this is very important, a function is a relation. So it is a relationship between x and y. But it is special in that each x value occurs only once. So if you want to think of this in biblical terms, this is the husband of one wife, right? Okay, our wives are not going to have multiple husbands or anything like that. So each x is only going to appear one time. Okay, that might be deceptive there. You can have, in math, you are going to be able to have y values occur multiple times, but not x values.
So that's going to have to be clear?
Well, it's going to be clear here in a moment. All right, so a set can be represented lots of ways. So I'm going to first represent it in what's called set notation. And I'm going to say f of x is this set. Notice this weird bracket right here. And then I'm going to put some numbers in here. So 4, 2. You want to write this really clear. Don't be a slob. And I won't give us many numbers here. Okay, so that's going to be our function. Over here, where this f is, that's the name of the function. Its name is f. Usually in math, just for shorthand, we just use one letter to represent the name of a function. This is my independent variable. Now, we're so used to multiplication, we might think that this means f times x. You just need to recognize when you are doing set notation, and when you are, or function notation, that in this case does not mean to multiply. All right. Let's see here. Let's first talk about, well, is this a relation? Does this set a relation? And the answer is yes. Well, why is it a relationship? Because I have ordered pairs. Each of these things is an x and y. See, x, y, x, y, x, y. So the things I'm underlining in red, that's the first thing, the second thing, the third thing. Relationship 1, 2, and 3. Okay? I have 3 relationships here. So yes, that's a relation. Okay? Next question. Is it a function? Now, if it's not a relation, it's definitely not a function. A function has to be a relation. And the answer is yes. Well, why? Each x appears only once.
What does it mean whenever you say each x appears once? So it won't be 4 and 4?
I won't have 2 4s.
Okay.
Right. So I have a 4. If it's a function, I won't have another 4 in the x's. Now, I could have it in the y's. But you see, I have 4, 3, and negative 5. So now, since we have a relation, we have a function, we might ask the next question, what's the domain? Well, the domain is all the possible x's. Well, what's my domain? I might write D for domain, and I make a new set. And I list in it all the things, 4, 3, and negative 5. You may want to put those in order. I'm just good for the ease of today. I'm just going to write them in the order they appear. Do you see where I got 4, 3, and negative 5? And then we might go on to the next question. Well, then what's the range? And that's all the y's. And I might say R is equal to 2, 1. Now you might say, well, here's another 1. I don't list it again. Don't list repeats. Now I say that, and there's always that one student who just always wants to list every number and not even think about it. Don't list the repeats. One's in my domain, or one's in my range, I don't need to list it again. Any questions where I got any of this? We'll do another example just to make sure that we're on the same page. Now I'm going to copy a portion of this just so I can do the next thing. Hopefully that gets it all copied. All right, let's go to the next slide here. Paste that. All right, so here's our function from before. You don't need to write it down again because you already have it. All right, so this is the set notation. I could write this in what's called a circle map. And a circle map is pretty easy. I make a circle here. I make a circle here. The one on the left is my domain. The one on the right is my range. All right, well, what's my domain? Well, we already listed it, 4, 3, and negative 5. See the x values. And over here on the right, the range, I have simply 2 and 1. And then what I'm going to do is I'm just going to draw an arrow. 4 goes to 2, do you see why? And 3 goes to 1, do you see why? And 5 goes to 1 as well. Do you see why that's the case?
No.
Because look up here at my ordered pairs. 4, comma 2. So 4, 2. 3, comma 1. So 3, 1. And likewise, negative 5. Negative 5 goes to 1. Any questions on the circle map? Make sure you get that down. Because in your work here, around a quiz or on a test, you might have the set notation, you might have the circle map, or you might have the next one. The next one, now I'll paste it again, you don't have to write it again, we're using the same example over again. The next one is a table. The table is pretty easy. x, actually all of this is pretty easy. You're just reading numbers off. 4, 2, 3, 1, -5, 1. Do you see how I did that?
If this is negative, like, say it's -1, would you count that as a repeat or no?
No, that's a different number.
Okay.
So we did one that was, now this is mainly for honors, but I want you all to see it. What if I wrote f of 4? That means I'm asking, well, if x is 4, what's y? Well, I look at my thing. If x is 4, what's y? 2. 2. And what if I wrote f of -5?
1.
1. Good job. But now, here's a trick question. What if I wrote f of 10? Well, then you look up here and you're like, wait a minute. There's no 10. Right? So we write undefined. Okay, it's not there. Now I'm checking the x's. I don't check the y's, I check the x's. Now, we already talked about graphing. Do I need to go over how you would graph these points? Okay? Because that would be the next way, is to graph this. Let's do one more example set. So let's say I have, and this time I'm going to start with a circle map. And just for fun, we'll call this g of x. Let's get some numbers in here. And I'm going to do this drawing. I'm going to go like this. So I have some weird things going on here. So this is the circle map. What would this be in a set notation? Well, let's figure it out. So I'd write g of x equals, now I might run out of room here, so I apologize. I'll try to write small. What's my first ordered pair?
-3 to 6.
-3, comma 6, right? Now comma. So I have a lot of commas in here. This is one thing. What's the next one?
2.
2, 6.
2, 6, good. And the next one?
2, 5.
2, 5, good job. And the next one?
Oh, my.
7, 7, 5.
7, 5. So I didn't have it smushed there. But notice something that happened weird this time. 2 went to how many numbers?
2.
2. So x equals 2 appeared how many times?
Twice.
Twice. Therefore, this is not a function. X cannot repeat more than once. That's not even repeating. If any x happens more than once, it's not a function. All right, so I have my set notation. I can still ask what's the domain. So what's the domain?
3, -3, 2, and 7.
Yes. And what's the range?
6 and 5.
6 and 5. That's pretty easy. That's easy points. I've been telling you right away. Like the first question on your test at the end of the chapter is going to be something like this. So not that difficult. I don't think anyway. If I wanted to make a table, x, y, what would I put here? Well, -3, 2, and 7. -3 went to 6. Now 2 is going to be confusing, so I'm actually going to need to list 2 twice. So 2 goes to 6 and to 5, and then 7 goes to 5. So that's a weird table. And again, this is not a function. All right, now we're going to get into the math algebra piece. Let's say f of x is this. Well, now it's not a set or anything. This is a formula. And maybe I say in this formula, find f of 2. That means this number, I'm going to replace all instances of x with what?
2.
2. So f of 2, I'm just going to do my work over here. I leave myself some space. I work down Trey Gainey, not across my paper, work down my paper. Okay, I'm going to write my 3. I put parentheses, and I replace the x with 2, and I have minus 5. And then I follow the order of operations. So 3 times 2 is 6, and 6 minus 5 is 1. So the f of 2 is 1. Simple, you just replace that in. Alright, we'll have another function. Now this does not mean f times 2. Let's try g of x. Let's make another function. Maybe we have negative 3x squared plus 5x. I don't know what's with me in 5s and 3s today. Alright, let's find g of, let's do 2 again. So I replace each instance of x with what? 2. So I have negative 3 parentheses 2 squared plus 5 times 2. Order of operations, what should I do next?
Exponent.
Exponents, what's 2 squared?
4.
So I have negative 3 times 4. And I can go ahead and do this piece, that's 10. What's negative 3 times 4? Negative 12, so I have negative 12 plus 10, which is negative 2. Okay, so again, all I'm doing is I'm putting in that number in for x. Let's do one more. Let's say h of x is twice the absolute value of x plus 4. Let's find h of negative 8. So what do I do? Replace all the x with. So I have negative 8 plus 4 in absolute value. What's the absolute value? Or, well, first of all, I have to do everything inside the absolute value. So what's negative 8 plus 4?
Negative 4.
Negative 4. And what's the absolute value of negative 4?
4.
So I have 2 times,
4.
which is
8.
8. Okay, you do everything inside that absolute value first. Alright, luckily there is only 2 more things that we need to do. I hope you're not completely lost. Do I need to go back to that? Does everyone get that? Alright. Let's say I want to find the range for a given domain. This is most often what you would be asked to do. So I'm going to give you a function. Let's say f of x equals x squared minus 3x. Make it simple. And I'm going to say my domain is negative 3, 1, and 5. You're actually going to do the same thing that we just did, except 3 times. Well, why 3 times? Well, I have 3 numbers in my domain. So I'm going to find the f of negative 3. I'm going to find the f of 1 and f of 5. So I replace x with what in the first one?
Negative 3.
And notice how I put it in parentheses. What's negative 3 squared? Not negative 9. Positive 9. And what's negative 3 times negative 3?
Negative 9.
Yes. Well, positive 9, right?
Yeah.
So plus 9. 9 plus 9 is 18. Any questions how we get 18? Okay, the next one, I put in 1. So I have 1 squared minus 3 times 1. What's 1 squared?
2.
No. 1 times 1 is
1.
1. And 1 minus 3 is? Negative 2. And finally, I'm going to put in 5. So I have 5 squared minus 3 times 5. So 25 minus 15, which is 10. Now, you're going to be tempted to box this. No, 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 no. It said find the range. That's the work to get the range. My answer is range equals 18, negative 2, and 10. And this is the final answer. When I put it all together, you got to put it together. Any questions on how to do that? Does anyone need to see another example of doing that? Be honest. Going once. Going twice. Sold to Mr. King. Okay. So now this is what you need your graph paper for. So I'm going to my graph right here. And you don't need to be very picky about how you do this. But I'm just going to put some dots up here. Alright, so here are my dots. And we're going to say this is my relationship. So let's first go through, and I'll give you time at the end here to copy this down. Here's my x-axis, here's my y-axis. What is this point right here?
Right.
Negative 1?
Negative 1, 3.
Negative 1, 3. Good job. And this point right here?
1, but
1,
negative 1.
Negative 2. Okay, and this point here in the middle?
1.
3, 1. And this one down here, we'll do the one on the bottom. 4, what? And right here at the top we have
4.
5.
Yep, 4, 5. Good job. Okay. So now, I'm going to ask the question. What's this relation in set notation? So in set notation, I would write, well, this is f of x. And I would write, all right, well, my first point's negative 1, 3, right? And then my next point is 1, negative 2. And then my next point is 3, 1. Do you see where I'm getting all these points? I just read them off my graph, right? And then I have one more, so I'm just going to erase that y right there so that I have room. And then I have 4, 5. Any questions on where I got all those points? Okay, I've just labeled them. Now you don't have to do it the way I did. But now here's the next question I'm going to ask. Is this a function?
No.
And Ryan's right. No, it's not. And why not?
Because there's repeating x.
Yeah, I have a repeating x. I have 4. Happens twice. Now y's, listen to me, y's can repeat. It's the x's that can't. So I guess the wives can have as many husbands as they want.
You.
No, that's the, wait. Yeah. Wait. No,
mean
it's
the
the
husband?
husbands
Yeah.
can only have one wife. That's the thing. But the wives, I don't know. What kind of evil this math class is doing. Alright. I have a vertical line here. You can use your pencil, you can use your eyeball. But what I'm doing is what's called the vertical line test. If I have a picture, I really don't need to write all this down to figure out if it's a function. All I need to do is take a vertical line and ask the question, how many times does it cross the graph? Well, how many times does it cross right here? Once. How many times right here?
1.
Once. How many times right here?
1.
And right here?
2.
2. If it crosses any place in my graph more than one time, it's not a function. So I was good until the end. Right here, failed the vertical line test. Okay? And I right away know it's not a function. I'm going to quickly, go ahead and quickly get those dots down because I'm going to do one more picture to show you the vertical line test another way. And you don't need to copy the pictures I'm putting up. They're just for us to practice. Going once,
Goes 1.
Gone.
Right.
Okay. Alright, so here's my beautiful graph. I played connect the dots, I drew my graph, and now I want to know, is this a function? So I take a vertical line, and I pass it through, and I'm fine. You might be wondering right here, well, does it cross twice right here? Not really. There's like a resolution problem, like if I zoomed in on a calculator or something, it might be further apart. So we're going to say that this is okay. This passes the vertical line test. Okay, so that's a function. But then I might have something like this.
Oh no.
This is a weird thing. Now obviously, I'm good right here. But then right here, obviously I hit twice, 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 twice. So is this a function? No. This is not a function. It fails the vertical line test. I might have something like this. And in your future, you'll actually be graphing things like that. Alright? I'm good right here, but then I fail all over the place right here. So is this a function?
No.
No, that is not a function. Now, weird things can actually be functions. I might have something like this. Okay, welcome to pre-calc class. That's something that they might have to graph. And I take my vertical line if I want to know if this is a function. Now, I get right here and I might be like, well, it fails, it crosses twice. But you remember, open circle means don't include that. So we're good. And then we keep on going. Are we good? We're good, we're good, we're good. Now we have a big gap right here. Big gap? That's okay. Doesn't cross twice, does it? And we're good. So is this a function?
Yes.
Yeah, it's a function. It looks really weird, but yes, that's a function. Okay, I want to do a bunch of practices so we can put away our notes.